welcome to this explainer. If you're a focused learner looking to really understand the absolute cutting edge of offensive security, you are definitely in the right place. Today, we're mapping out this amazing, transformative journey. We're going from just relying on standard, prepackaged hacking tools to actually building your own custom exploits. We're going to look at the core concepts from Justin Seitz' definitive guide on using Python for offensive security. We'll be breaking down the exact techniques used to navigate, manipulate, and completely dominate target networks. It can feel a lot like navigating a sprawling, futuristic cyberpunk city in the dead of night. Deep shadows, towering structures of data, and you really need the right skills to survive.
I want to kick things off with this incredibly powerful quote right from the foreword of our source text, penned by Charlie Miller. He says, "The difference between script kiddies and professionals is the difference between merely using other people's tools and writing your own." Wow. That really sets the stakes for everything we're about to cover today. It's not just about knowing how to, run a scan. It's about knowing how to build the scanner yourself from scratch.
And really, this brings us to the core premise of our whole explainer today, adaptability. In offensive security, the ability to just whip up powerful tools on the fly, it isn't just a nice-to-have skill, it's absolutely indispensable. Because when you finally breach a highly secure environment, you almost never have the luxury of your perfectly configured home lab. True mastery means being able to adapt to whatever incredibly limited environment you happen to find yourself in.
Okay, let's dive right into this. We're going to explore the darker side of Python's capabilities. We are moving way beyond your basic administration scripts, and we're looking at how Python is used to write network sniffers, manipulate packets, infect virtual machines, and create some seriously stealthy Trojans.
Section 1. Script kiddies versus professionals. Here, we're really highlighting the distinct contrast between the amateur approach and the true professional approach. So, picture this totally terrifying scenario. You've successfully worked your way into the deepest, darkest depths of an enterprise target. You have network access, right? But you face a huge problem. You have an empty toolbox. There's no Netcat, there's no Wireshark, there's zero compiler, and you have absolutely no means to install one. Now, amateurs? They just stop here. But professionals recognize the ultimate workaround, the Python Swiss Army knife. Because in a lot of enterprise environments, you'll actually find a native Python installation just sitting there. And if you know how to code, that single installation lets you build sniffers, clients, and proxies right there on the fly. It's a total game changer.
Moving on to Section 2, Mastering the Network Foundation. Let's look at how we manipulate the network when we don't have access to those standard tools. The absolute fundamental building block for literally all network manipulation in Python is the socket module. This single module exposes every necessary piece you need to quickly write TCP and UDP clients, servers, and interact with raw sockets. Honestly, for the purposes of breaking in or just maintaining access to a target machine, this module is practically all you really need. It's the whole shebang.
So, we have our problem, right? No Netcat, no Wireshark. Well, the solution is just writing our own Python TCP proxy and host discovery tools. By using raw sockets, we can access lower-level networking information, like raw IP and ICMP headers. This lets us sniff traffic natively on both Windows and Linux. And then, when we introduce a library like Scapy into the mix, oh man, we can decode IP layers, manipulate packets, and even steal plain text credentials directly off the wire. We are effectively replacing those missing tools with our own custom code.
Let's pivot to Section 3, Custom Web Hackery. We're moving from the network layer up to active attacks, focusing on the absolute largest attack surface in modern enterprise networks.
And Python also brilliantly integrates into established workflows. Take Burp Suite, for example. It's one of the most popular web hacking tools out there. But a professional doesn't just use Burp straight out of the box. Through tools like Jython, you can write custom Python extensions and fuzzers that plug directly into Burp Suite. What this means is you can customize Burp's behavior to attack highly specific proprietary web apps that standard off-the-shelf automated tools would just completely fail to understand.
But beyond extending Burp, creating your own standalone web tools is absolutely vital. The bread and butter of web hackery involves brute forcing hidden directories, automating HTML form authentication, and writing custom scanners to map out the exact file structures of open source CMS installations like Joomla or WordPress. These custom scripts are what uncover the hidden, misconfigured flaws and those pesky leftover installation files that standard scanners just completely gloss over.
All right, now we transition into the deeper, darker side of our explainer. Section 4, Building Stealthy Trojans.
Because once you finally get a foothold, how do you actually keep it? Let's look at how to build a truly resilient attack infrastructure. A major headache for attackers is that standard command and control, or C2 traffic, almost always gets blocked by enterprise firewalls. So the brilliant workaround here? Using GitHub for your C2. Your deployed implant checks a GitHub repository over encrypted SSL. It retrieves its configuration data and then automatically downloads new custom Python modules. And because it's using standard SSL to a highly trusted site like GitHub, it blends in perfectly with normal, everyday corporate traffic. No one even blinks.
Okay, so once that Trojan is securely communicating, it obviously needs to perform tasks. Here are some of the common Windows Trojan modules you can build. You can use PyHook to trap keyboard events for keylogging. You can use GDI programming to silently snap screenshots. You can even allocate memory buffers to execute shellcode directly. But honestly, my absolute favorite part of this whole cat and mouse game? It's how you can detect if your Trojan is running inside an antivirus sandbox. You just monitor for actual human user input, like mouse clicks and keystrokes. And if the Trojan doesn't see human behavior, it literally just plays dead and stays totally quiet. How cool is that?
Which brings us right to the climax of our explainer. Section 5, Escalation and Offensive Forensics. How do we take that limited access and turn it into total system control?
Here is the classic privilege escalation problem. You have a low-privilege shell, sure, but you really need system-level access. Well, a highly creative Windows privilege escalation trick is to monitor Windows Management Instrumentation, or WMI. Basically, you look for automated high-privilege scheduled tasks. Usually these are EBS script or PowerShell scripts set up by the sysadmins. And because these scripts often have pretty poor access control lists, your custom Python script can actually win the race condition. You just modify the sysadmin script a split second before it executes, effectively injecting your own code to run with system privileges. Just a brilliant maneuver.
So, the crucial point we're making here is that true professionals don't just use offensive tools, they turn defensive tools into weapons. Take the Volatility Framework, for instance. It's an advanced memory forensics framework built in Python, and it's typically used by incident responders to analyze malware. But offensively, oh man, you can use it to rip password hashes directly out of a target's memory, or seamlessly inject shellcode right into running virtual machines. It is literally a masterclass in using the system against itself. And that brings us to our final thought. We've seen how Python empowers you to adapt to any environment, from raw network sockets all the way to stealthy GitHub C2s and offensive memory forensics. The philosophy here is crystal clear. Imagine you're deep inside that heavily guarded network, navigating it like those rain-slicked streets of a dark, cyberpunk city, and you find yourself staring at a blank command prompt. Are you going to be helpless without your prepackaged tools, or will you build your own? Thanks for joining me on this explainer. Keep learning, keep building, and I'll catch you in the next one.